Coming to the next type of classification, we have got isovalent or heterovalent kind of hyperconjugation. This is with respect to the number of bonds which are present when we are writing two different structures written after the delocalization. The focus is on the number of bonds. Are these values changing? If they are changing, iso, that is same, and if they are hetero, different, it is heterovalent. And heterovalent is basically also called as sacrificial. The reason is at least one of the bond is being sacrificed. If you say sacrifice, that means there should be less number of bonds. So when we say isovalent hyperconjugation, this is the same number of the bonds which are present earlier in our molecule, and in the next structure which we are writing after hyperconjugation, there also we are having the same number of the bonds present. That happening, we are calling this as isovalent hyperconjugation. And we can also see the structure which we will be drawing just after this. We will see that is going to have a kind of double bond and no bond resonance kind of situation, but the total number of bonds are not changing. See here, the ethyl carbocation we have seen there are total 6 bonds present. 1 carbon-carbon bond and 5 carbon-hydrogen bonds are present. But as a result of hyperconjugation, if we are delocalizing these electrons from carbon hydrogen bonds over to this empty orbital of the carbon, then what is changing? This hydrogen is being lost as H plus over here, and then this pi bond is being formed over here, this one. When the pi bond is being formed, the total number of bonds are not changing. 4 carbon hydrogen bonds are present and 1 carbon-carbon single bond and another carbon-carbon pi bond. Basically the pi bond we have to count here separately as a different bond. That's why in the beginning we have said this is supposed to be considered with respect to the 2 electron bonds. So pi bond is separate, sigma bond is also 1 2 electron bond, and another pi bond also is 1 2 electron bond. Sigma and pi bond should be counted separately for that when we are considering the isovalent hyperconjugation or even heterovalent hyperconjugation. So this is how they will be counting the number of bonds in this valent type of classification for hyperconjugation. I hope that's clear, right? See, now when it comes to heterovalent, the thing is the valency is not going to, not valency basically, the number of the bonds which we see are not going to be same. And because it is sacrificial, then the one bond is being less. So that normal 2 electron bond what we are talking about, this is at least 1 bond less in comparison to the first structure when we are trying to do or trying to show the delocalization of electrons taking place. And rightly said, because one bond is being sacrificed for the sake of hyperconjugation, we are calling this as sacrificial hyperconjugation. See here, we have got propene and total 9 bonds we are having here. Out of those 9 bonds, there are 3 carbon-carbon bonds and 6 carbon-hydrogen bonds. Out of those 3 carbon-carbon bonds, one of this bond is pi bond over here, and 2, one of this and one of this are carbon-carbon single bond, like sigma bonds. Out of these 9 bonds, when we are doing the hyperconjugation, we are shifting this electron here and this electron here. What we are getting? We are getting total 8 bonds left. One of this bond what is being broken over there, and one bond what is broken over here. In lieu of that, only 1 bond is being formed. So out of 9 bonds, 1 bond is missing now. That is what we mean to say by sacrificial hyperconjugation or the heterovalent hyperconjugation.